There are three main buffer systems in your body: the bicarbonate buffer system, the phosphate buffer system, and the protein buffer system. Let's begin with the bicarbonate buffer system. This is going to be the main buffer in your extracellular fluid. It involves the reaction below. To the left of the arrow is carbonic acid. To the right is bicarbonate ion and hydrogen ion. If you have a solution that is too alkaline, the carbonic acid will dissociate into bicarbonate ions and hydrogen ions. These hydrogen ions in turn will bring the pH back down. If, however, the pH is too low or too acidic, the bicarbonate ion binds with the hydrogen ions, removing them from the solution and forcing the equation to go to the left, producing carbonic acid. Your buffer here is the weak acid carbonic acid and the weak base bicarbonate ions. The bicarbonate system controls about 65% of all of the hydrogen produced. Let's look at this illustration. In the middle, I have carbonic acid. Notice that the arrows move in both directions. Let's move to the left toward the lungs. The carbonic acid can dissociate into carbon dioxide in water. The carbon dioxide then can be expired through the lungs. Getting rid of carbon dioxide will allow the pH to come back up. However, notice the arrow also goes in the opposite direction with the lungs. If the pH begins to become elevated or too alkaline, you can actually retain carbon dioxide, and that will allow the pH to come back down. Thus, your lungs regulate your pH on a short-term basis by regulating the rate at which they get rid of carbon dioxide. Let's look at the kidneys next. We're going to follow to the right of the carbonic acid. Notice that carbonic acid can dissociate into the bicarbonate ions and the hydrogen ions. We'll be looking at how the kidneys regulate your blood pH by regulating the amount of bicarbonate ion. They can either retain or secrete bicarbonate ions. We'll go into this further. A second buffer system is the phosphate buffer system. It will be very similar to the bicarbonate buffer system. This is going to be an intracellular buffer system, as well as a system that helps regulate the pH of the fluid within the renal tubule. The third buffer system is the protein buffer system. This buffer system is the main intracellular buffer system, and the most important of the proteins is hemoglobin. About 60 to 70% of the total chemical buffering of the body fluids happens inside the cells. And hemoglobin is a very good buffer system. Let's look at how this happens. Recall that an amino acid consists of an amine group, a carboxyl group, and an R group coming off of a central carbon. That amino acid can either gain hydrogen ions, which you can see there in the purple, or give off hydrogen ions, such as in the blue. In this way, amino acids can help regulate pH and thus function as buffers. Let's review. What is the main extracellular buffer? Recall that it is the bicarbonate buffer. What is the main intracellular buffer? It will be your proteins. Let's review how the lungs regulate your pH. Remember that by regulating ventilation, you can regulate the amount of carbon dioxide that you retain in your blood. As carbon dioxide levels go up, pH drops. As carbon dioxide levels go down, pH goes up. Thus, by regulating how quickly we eliminate carbon dioxide, we can regulate our blood pH.